Good day, everyone. Welcome to CppChat. We're here today with Bryce and Howard, and going to have a good discussion, I think, coming up. So let's start off by introducing Howard. This is your second time on, but for those of us who haven't seen previous chats, go ahead and let us know what you're about, Howard.
Well, thanks for having me on again. As John said, my name's Howard Hinnant. I'm a software engineer for Ripple, and I've been working in C++ for, gosh, longer than I like to think about. Been participating in the committee for since 1998. Served as LWG chair for 5 years, 2005, 2010, and having a lot of fun with it.
You downplayed your real achievements. You made the MetroWorks standard library standard compliant.
You're showing your age now.
Yes. and you created the library for Clang, lib C++ from scratch, right?
Right.
And you did a little bit of work before Apple put you on that assignment. You did a little bit of work on the lib standard C++, right? The GCC implementation.
Oh, nothing to speak of. No, not really.
But a little. And I mean, what I'm saying is you worked on 3 different standard library implementations. Is there anybody else who has that kind of background?
I'm sure there must be. I don't know. I haven't done the survey.
All right. Okay. So, and we also have Bryce on this morning. Bryce is always quick to remind us that it is morning, and
It's
early morning. It's not even 10 o'clock yet.
It is not even 10 o'clock yet, but I am here and conscious.
Tell us about what you're doing.
So my name is Bryce Adelstein-Lelbach. I work at Lawrence Berkeley National Labs, and I am the lab's C++ committee representative, and I work on a number of different projects relating to high-performance computing.
Okay, excellent. Well, I'm really glad to have you guys join us. So one of the things that I wanted to talk about is something that was on, someone asked a Stack Overflow question about this in the ISO.cpp.org website, which, by the way, I assume most people listening to this probably are familiar with it, but if you aren't checking that at least once a week, you're probably missing out, because all the interesting stuff, they troll all the interesting stuff in C++ to put on ISO.cpp.org. So that's a great place to you should check in at least once a week. Anyway, so they highlighted this question about specified order of parameter evaluation for C++. So this is this kind of gotcha where particularly beginning programmers will make the assumption that as they read the parameters from left to right, that's how the compiler is going to evaluate the parameters. And so and most of the time it doesn't matter, right? 'Cause almost always your parameters are completely independent of each other. But beginners might do something like pass, I++ and then another I++ or something like that, and then the behavior is all indeterminate or something like that. So the question was on Stack Overflow, but the interesting thing about it is that the standard committee has actually begun to address this. Can you summarize for us, Bryce, exactly what the committee has said?
So at ULU, we voted to adopt the paper proposing Gabby's paper is proposing a specification of this, and so I think the new rules are the order of evaluation of an expression. The postfix expressions are now would be evaluated left to right. Assignment expressions are evaluated right to left, and operons to shift operators are evaluated left to right, with a special caveat for the function calls, which is that the function calls are specified that the function, so at an f(abc), the f will be evaluated before abc, but then a, b, and c will be indeterminately sequenced. So that part was the alternate part of the paper. Whereas the actual proposal had wanted to specify the actual ordering for function call expressions. But so it specifies a specific ordering for everything except for function call expressions, which have this indeterminately sequenced for the arguments, but with no interleaving in between them.
Okay. So this is one of those things where people who teach C++ actually be able to explain to beginners that the order of evaluation is not determined, and therefore, this is how we can charge big bucks to do training. But it turns out that C++ is just complicated enough that we don't really need to make it mysteriously more complicated in order to justify our work. But the question is, why has it been this way? Why is it indeterminate? And I guess the obvious answer is that the thinking is that compilers can optimize cases of some sort. Now the question is, does that actually happen, and how much is this costing us? Certainly, I think, arguably, it's going to make it a lot easier to teach C++ and a lot less likely that people will stumble onto indeterminate behavior without realizing.
So I should first note that I was one of the handful of people who voted against this proposal, and I can explain why in a little bit, but I don't necessarily think it's a bad idea. I had other issues with it. Basically I think we haven't studied this enough to specify it this way yet. Basically, my understanding is that currently, at least for the function call piece of it, there's no compiler that optimizes based on this, but there are compilers that pick so right now I believe there are different compilers pick a different order. So right now I think like GCC picks left to right for function calls, let's say, and MSVC picks right to left. Now I think I don't know whether those are correct or not, but I do know that like it's different between different compilers. And so that was one of the reasons why the alternate version got voted in, because if we had specified a particular order for the function call evaluation, then some compilers would have had to change, and those compilers were concerned that that might be a performance hit for them. But nobody actually goes and does these optimizations of looking at, oh, well, we should evaluate these arguments to this function in this order because performance. At least that's my understanding. As far as the other parts of the proposal, I would believe that it's the same case, that different compilers probably just pick some order, but they don't do any actual optimizations here. But I'm not sure that this is going to always be the case, in particular for if you have a compiler for a platform that's not an out-of-order execution platform, so like a GPU platform. I'm not certain whether those sorts of compilers might have these optimizations where it might matter more for them. I voted against this proposal because I was not motivated by the performance analysis, the performance results that were cited in the paper as justification for the paper. So the numbers that were presented, it was unclear to me what the benchmarks were that were used. It was unclear to me how to interpret them, and I wanted to see more of a rigorous scientific study of the effects of this before it was adopted. But I was in the minority in that viewpoint, and it was voted in as is with the alternate version of the wording for function call evaluation order.
Those scientists always wanting their studies. Jeez.
Yes. I posted a long rant on Reddit about all of the issues I had with the numbers.
Come on, we deal with feelings, not facts.
Yes, because feelings, we can get feelings within microseconds, or maybe fractions of seconds. Okay, but facts, they take a long time.
So Bryce, do you know if a compiler has to change order, if that would be an ABI breakage for the compiler?
That's a really good question. I think the answer is that is probably no, because I imagine that there would have been more objections if that had been the case. It might be that the answer is it would be a breakage, but it wouldn't be a breakage for any major compiler in practice. Trying to think about whether I'm not certain. That's a good question, though.
Luckily, I don't have to worry about such things anymore. I'm extremely happy about that. But I'm just curious.
So in the chat room, MTT is asking, isn't the non-guarantee needed for common sub-expression elimination? And I don't think it is, right? Because the only time it makes a difference is if there's a side effect that would be noticeable. So for common sub-expression elimination, you only do that if you know there's no side effect anyway, right? Yes?
Right.
So I think it's not needed for there. Actually, what most scared me was in your listing all the other things. For order of parameter, I'm confident about that. I don't think about, I'm cognizant of that when I call a function. I realize that parameter evaluation is indeterminate. But some of the other things you listed, it starts to scare me. It's like, oh, maybe I've been making assumptions that aren't valid.
I think, generally speaking, if you're relying, I don't think good C++ code is broken by this. I think only bad code would rely on a particular compiler's weirdness here that would be specified by this.
But you were saying something, for example, if I was streaming out a bunch of things to see out, that they might be evaluated in some interesting order? I guess it only matters the side effect is all that matters. And you don't generally write out things that have side effects as you write them out. I mean, you could, but...
Yeah, I don't think if your code is broken by this, I would be interested in seeing your code. But I suspect your code would probably be bad.
That's not what I was worried about. What I was worried about is code that I was writing that was broken now, but I wasn't aware of it. In other words, if my code is fixed by this, that's what worries me. Do you see what I'm saying? Because that means that I was inadvertently writing things that depended on order of evaluation without realizing that I was doing it. So that's what scares me, is if my code is fixed by this bug, that means I've been writing bugs. Fixed by this change.
I think that was one of the things that came up in the discussion. Yes, I would kind of agree with that. I don't know that I feel qualified to say more than that.
Okay, all right.
I think in general this is a good idea, and I would be in favor of it if I felt that I understood why this hadn't been done in the first place and what the potential performance implications are.
Right. I feel like I have no idea. I'm not a compiler implementer, but I guess what I would expect is that if this has implications, then first of all, it wouldn't have come from Microsoft, because I'm sure that this was run past the compiler team before. I mean, I don't know what Gabby actually is working on. I don't know if he's on the compiler team. I'm sure he's working on Visual Studio somewhere, but I don't know if he's working on code generation. So I don't know but I'm certain that he wouldn't have published it without running it through Jonathan Caves or somebody like that, right?
And his name's actually on the paper.
Oh, okay, all right.
So I hope he ran it by him.
Yeah. So if the Clang team, I don't know, is there anybody who shows up who's actually on the GCC team other than Jonathan Wakely? I've never met anybody who I knew was working on GCC.
I don't want to speak for other people, but I don't think any of the major compiler backend people were voted against this. I think some of the GCC people and some of the Clang people were in favor of this, given the caveat of the alternate version of the proposal where the ordering for function calls was left unspecified. Again, I don't want to put words into people's mouths, but I don't think any of the compiler vendors who were there felt that this was a big enough issue or that they had big enough concerns about this to speak out against it in plenary.
That's interesting, and that kind of calms me, because it's the kind of thing where you want to let the compiler writers have this leeway, and you don't know how good a job they'll do with it. But if the compiler writers themselves, and it's not what they're doing now, it's what they think they might do. I mean, I assume that if you're maybe you could think about this from the point of view of a library implementer, Howard, which is that you've got this really long list of things you want to explore. Could we optimize this? Could we optimize this? Could we optimize this? And maybe they're not at the top of the list. But you wouldn't want somebody to come along later and say, well, you're not using any of these optimizations, let's preclude them. And you'd freak out and say, wait a minute, I can imagine fixing this in the future. Maybe not fixing, but I want to explore, could we do something here in the future?
Sure. In fact, I run into stuff like that all the time, where I'm frustrated that the committee has already forbidden, optimizations here and there.
Yeah.
So I can definitely understand the motivation of being cautious about this type of thing.
Yeah.
One of the things that this paper fixes that is notorious is, like, if you've got a function taking two unique pointers and you construct each unique pointer with a new, instead of using make unique. Theoretically, that used to be a potential memory leak, and this fixes it because it now, with the non-interleaving aspect of this paper.
Right.
Yeah.
That's the famous gotcha that Herb published a long time ago, and I think it is Guru of the Week.
Right.
And I put it in my exception safe talk. And I remember it was you, Howard, who once asked me the question. He said, do you know any compiler that would actually generate code that looked like that?
Right. And that's probably why they were able to get this paper through, is because no compiler probably took advantage of that. And nobody could see a reason why they'd want to.
Right. Speaking of implementations, so this class that I've been in for the last week, it's an interesting class, because the reason I'm taking it is because the company wants me to take over teaching it, so I was taking it. And one of the things that we talked about, we're creating this library of an object that is a wrapper of data, and so in a lot of ways it's a little vector-like. And in fact, it uses vector internally, but one of the issues was, would it be possible to do an insert of a range of iterations without worrying about aliasing? Do we have to specifically call out and say, if you alias, then behavior is undefined? And what was interesting is we did figure out a way of doing this that we felt like we could actually pull this off. And what I was most concerned about was that with aliasing, we actually had two versions of the call. One version of the call passes in effectively a pointer and a number of bytes. So we can figure out if we are aliased. We can look at that and say, oh, that's pointing at us, so that's fine. But with a pair of iterators, of course, the iterators could be iterator wrapped. They could be reverse iterator. There's all sorts of things that can be done, and we have no way of knowing if it's pointing at us. And so we can't figure out if we're being aliased. So you have to figure out, can you do this insert in a way that you don't overwrite any of the existing data until after you have copied everything. And someone pointed out that if you look at the standard says that the behavior is undefined if you do aliasing. But somebody looked at the implementation of lib C++ and figured out that you guys had figured out a solution that even if aliasing happens, it still works. And I just wanted to say I was quite impressed. You went way above what the standard says, because the standard says behavior is undefined, and you said, okay, well, we'll define it to do the right thing.
That's interesting. It has been several years since I've worked on that, and I would have guessed just the opposite, that it will mess up if you alias in libc++.
Well, at first I was thinking that the first thing is you figure out how much space you need by doing a distance on the iterators. And then I was realizing, wait a minute, it could in fact be input iterators. right? You're just doing an insert. So you can't do a distance. That's just not legal for you to do on input iterator.
Well, we do a test on the type of iterator first, and then there's two different algorithms, input and then everything else.
Sure. But it is possible, and I didn't realize this at first, but with our design, somebody else had to point this out with what we were doing. Say, well, here, we can do this, and then we can do this, and then we can do this. It's like, oh, I guess you could do that. You do this final rotate at the end.
Yeah, that's for the input version, yes.
Yes, and it can be done. It can be done. And I was thinking, well, it probably can only be done if you know for certain that you're going to allocate a new buffer. But if you're trying to do it in place, you almost certainly are going to have to overwrite before you're finished. And no, someone showed me how it was done and then pointed out it looks like that's what libc++ is doing. So, I don't know.
Yeah. The algorithm with the input iterators, just for everybody else, what you do is you append the range onto the existing vector, and then you rotate it into place after you've copied it in. Right. And it's actually Sean Parent that taught me that trick.
Yes. Well, Sean, rotate is this weird thing, which turns out to be really useful. But when you read the description of it, you say, why is this here, and when would I ever use it? and then it turns out to be kind of handy.
Oh, handy all the time. And it's also a wonderful algorithm to try to optimize as much as possible, because it is handy in so many places.
Oh, and so there's some nice little optimizations you can do for rotate, huh?
Oh yeah, and there's also some nice optimizations that everybody thinks work and are actually not. For example, there's a famous algorithm for rotate using bidirectional iterators where you always swap things 3 times, and it turns out that is the absolute slowest way you can do something. If you only have forward iterators and you use the forward iterator version of the algorithm, it's actually faster than the bidirectional version of the algorithm.
Wow.
On average.
So you're saying it works, it's just not an optimization.
It's a pessimization.
It's a pessimization.
if you take advantage of bidirectional iterators.
Wow.
Which I think, I'm not sure, it's been years since I've checked, but I think some of the standard libraries actually did do that pessimization.
Wow, yeah.
libc++ did not.
All right, so what else do we want to talk about? Did either of you guys listen to CppCast this week? They had a fellow named Michael Afanasiev. I don't know how to say his last name. But it was a very interesting talk. Michael is I'm not sure his title, a geophysicist, a geologist, something like this. I think it was a geophysicist. And he was talking about a project that he was working on to...
Geophysicist, yeah.
A geophysicist, okay. His project, what they're doing is, well, the way he explained it, he kind of gave the simple model. He said, we're actually doing something that's not quite this way. But what used to be done is people would map out the bottom of the ocean by dragging these very, very large things, like on the order of 1 kilometer by 5 kilometers or something like this. This really huge thing. And what it would do is it would just explode air. So it would make a large noise, essentially, on the surface of the ocean. And then they would watch the sonar blips, and when the sound got back up to the boat, then it obviously had gone all the way down and bounced back. And they would listen to how long it took to do that to figure out how deep the ocean was. Now, the problem is that you're actually going to have the possibility that the ocean wave, or the sound wave, will penetrate the bottom of the ocean and then hit something underneath the ground that's very, very solid, more solid than the bottom of the ocean. In other words, the bottom might be kind of muddy. And so then you hit this other thing, and it bounces back. And so you get this kind of echo. But it's okay, because you're just ignoring it, because you just want the main sound that represents the bottom of the ocean. But if you had really sophisticated stuff, then you could actually do further. And so that's what they're doing, is they're actually looking at, whenever you have an earthquake, and looking at the sound that's bounced back. And so they can find areas under the earth that are either a void, which might be completely empty, or it might be a liquid or something else, or it could be much more solid, a more solid kind of rock. And so you get this bounce back effect. And trying to reverse from the sound you get into, well, what is the path that that wave took to get here, is computationally very, very expensive. And he said that they're looking at a quintillion number of evaluations, where that he said it's 10 to the 19th. That's how many calculations they're doing, and it's just kind of mind-boggling. And so they're using C++ to do this. And he talked about how, because the way they're mapping this is essentially a huge object-oriented problem. In other words, they have these little pieces of data that represent, I guess, I don't know, volumes of Earth, or maybe it's waves, something like that.
So quintillion is what we would refer to in HPC as exascale levels of computation. So on order of magnitude of an exaflop or an exabyte of memory.
Okay.
So that's the next generation of supercomputers. That's largely what I work on, is those sorts of systems.
Yeah.
So it's very large-scale problems.
Right. And they figured out how to do this. They're using he referred to it as object-oriented, but he also explained that all the object-orientedness is done with templates at compile time. There's no virtual functions going on, because of course when you're talking about that number of operations, that many virtual functions would be pretty significant overhead. Anyway, it was very interesting, and he talked about using other kinds of languages to do this, things that would also be very object-oriented friendly, but of course the overhead on those was pretty significant. So they ended up at C++, and he talked about that. I enjoyed the talk a lot. I don't know that I really got all of the geophysics, but enjoyed it quite a bit.
I'll take a look at that. That's pretty cool.
Yeah, I had not seen it, but it is definitely on my to-do list now. That sounds very interesting.
Yeah, I'm loving CppCast. I will say that it was part of the inspiration for me to put together CppChat, because I just liked having different points of view and people digging a little bit deeper on what they're doing. Let's see what else we have. Also, there was an interesting kind of post on a blog called Prog Stuff, I think it's the name of the blog, on string interning, which at first I kind of wondered what he was talking about. But essentially what they're doing is they do a lot of, I guess, web page stuff. And so they have lots and lots of strings, but they're constant strings. And so they have this large buffer of strings, and essentially using what is now in the standard as StringView. In other words, it's an object that represents a string, but doesn't own the data, right?
Right.
And I think this is similar also to an extension that you were proposing, right, Bryce, or something like that, to make an array view?
Yes.
But people were objecting to the name because, unlike with a string, basically with a string you're going to want to treat it as write-only, because if you're going to, read-only, because if you're going to write to it, it's likely you'll change the length, and that's going to overwrite neighboring strings, and it's going to be a mess. But with arrays, you very often want to change data without actually changing the size, right?
Right.
So people were objecting to your calling it a view?
I objected to calling it a view.
Oh, I see.
We will bike shed a better name for the multi-dimensional array abstraction thingy, but right now I think we're calling it, I don't know, array ref, array span, some placeholder name. It's a bad name. We'll come up with a better one.
Right. And is it the case with StringView that you cannot change the characters?
Yes, that is correct.
All right. So is there an abstraction that allows both? In other words, it's non-owning, but it is mutable?
Yes, something like array view, but doesn't have this.
No, I mean for string. Is there something in the standard for that?
No, there is not.
Okay. I can imagine that use case.
There's, span or array view, which are essentially the same class of thing, would be the closest thing, but the issue is that they don't have all the string function overloads. The proper way to resolve this issue would be for string to not have all of the string algorithms embedded into the class,
Yes.
because then it would be easy. Then we wouldn't have to worry about having these abstractions. But what you gonna do?
Yeah, yeah.
Got to work on that time machine.
Yeah.
That's right. Standard library is pretty good for what it is, but I think that's an area most people will agree was not as foresightful as many other parts of the library. But this is actually something that we used in the search engine at Amazon. You could make changes to the index as long as you didn't widen the field. And so we had essentially the same sort of problem we were solving, which was that you didn't own the bytes, but you could modify the bytes, but only if you didn't lengthen the bytes. And so this was significant. And so we actually would divide up updates to the index into those which required lengthening fields and those which could just update fields in place. And the way the search engine was actually designed, it had two different indexes. One that was the main index that was really optimized and could only be updated in ways that wouldn't change the size. And then there was this other index which was much easier to optimize and generally had much less data in it, and it just contained the updates. So the one thing you could do in the other one, other than update in places, you could say this record is no longer here. You could delete it essentially, so that you would know to look in the other index for the update.
Interesting.
Cool.
Yeah.
Last weekend, speaking of strings, I had a need for compile time string manipulation, and not only just being able to create compile time strings, but append them, or even do integer to string conversion and that sort of thing. And so I whipped up something for that and was very impressed with how easy it was to do that. It requires C++ 14, of course. You can't do it in C++ 11. At least I don't know how to do it in C++ 11. But I was amazed at that it actually worked as advertised. The C++ 14 language came through, and I was able to create fairly complicated strings absolutely all at compile time. And the string would just end up in a register or in ROM when I looked at the assembly.
What did you use for your compile time string representation? A constexpr array of characters?
That's exactly correct.
Yeah. I think you can do it in 11, but if you do it in 11, I think you need to use a some class that takes a variadic pack of characters, and so your lookups are not linear or not O1.
Yeah.
So I think you can do it, but it's slower.
Yeah.
I also recently had a use case for this, which is that I want to have a like a meta spirit that can not only generate your parser at compile time, but can also parse compile time input.
That sounds good. I was also recently looking at structured bindings. That's a new feature coming down the pike in C++ 17, where if you've got tuple-like access or public data members, you can now it's much easier to return multiple values from a function. You guys, I'm sure, know if you do it with tuple now, you can use this tie facility to take existing objects and have them be assigned to from a function call. And with structured bindings, you can now declare and construct them all in the same line instead of constructing them first and then using tie to assign to them. And that looks very handy to me, and I think that might actually start influencing the way I write some of my code, either providing more tuple access or just when there's no invariance, making the public data members, making the data members public.
Oh. We have discussed it. We talked about it when Bryce was kind of talking about the things in C++ 17.
Yeah.
And I think this is really cool because essentially what we've done is we have allowed C++ to now return, have multiple returns. Not multiple places of return, but multiple return values. And we've kind of had that because when we had tie, that allowed you at any time to say, oh, I want to return, as the standard library does, I'm going to turn a Boolean to tell you whether or not the items got replaced, and I'm also going to return an iterator to tell you where the location is. That's great. Except that you couldn't really do that, because if you wanted those const, if the caller wanted those to be const, there was no way to do that. You could only assign them to something you declared. And so that's what this structured bindings allows. And I think this is kind of the tip of the iceberg about what reflection can be, and I think that's exactly why there's pushed back with some of the facility. In fact, I think you were, Bryce, didn't you talk about this?
Yeah, yeah.
It's almost got what you want, but not quite, and it was deliberately not quited.
Well, the you can destructure anything that has that has components that can be accessed with get, either a member get or a global get function, like tuple and array. But also you can destructure these things that are these this class of structs that are destructible, so destructurable. And so that's classes that have all their non-static public, all their non-static members are public, and they all live in the same base class. But it's a little odd that like saying, oh well, this works with all these things that you can call get with, but we're also going to make it work with this class of structs. But there's no way to say, hey, I want to get a particular member of this type of struct. But if we'd added that functionality,
but you could write your own function that does nothing but return that struct, right? And then you could get it that way.
Yes, but you need to be able to know this. To be able to do that, and I tried to write that, you need to be able to know the number of elements in the struct. But so it's like it's very close to just being like to being a way of accessing members of structs sort of arbitrarily. But it's not just there yet. But hopefully we'll have a reflection TS.
I hope this doesn't encourage people to do what Howard suggested, which was having public data. I think public data is just not a good idea. And I'd hate to have people say, oh, well, it's the only way I can do this. I would rather have a way of opting in by saying, okay, well, I'm going to write a get function to do this, rather than...
Yeah.
I'd argue that there are cases where public data is okay, and those are the cases where you have no invariance among the data members.
Yeah. I agree 100% that there's no point in having a class that has getters and setters if you have no invariance between the data members. You might as well just make them public.
Pair is a good example of that.
Yeah.
And,
or a bad example, depending on your point of view.
Complex is actually another good example, only in the standard those are private. But I think those could have just as easily been made public.
Right, given that there's no constraints on them. There's nothing that you can put in complex that's not valid except not a number, and we can't fix that. So.
Right.
Yeah. Okay. So I think there might be some interesting reflection stuff coming out of this. I would. It's an interesting direction.
Yeah, maybe it'll evolve much like const expert has. That would be great.
I hope it doesn't secretly turn into reflection, because we're going to actually get proper reflection down the pipeline.
You know this?
Bryce is on it.
Well, so the reflection study group's making a lot of progress with the reflection proposals, and I'm pretty confident that we're going to continue making forward progress on reflection.
Okay. All right. Anything else that we should talk about?
So I had to write a nifty algorithm this week. I could not find a way to do this with the standard algorithms. So here is the problem I was trying to solve. A particular thread. So a lot of my work boils down to I write thread schedulers for a bunch of different projects. So I had a particular thread scheduler where I had some vector of threads, and in this vector, the elements were ordered in such a way that their neighboring elements were sort of physically close to them on the system, in a way that it would sort of depend on the different system. But like generally speaking, like there would be different levels of numer hierarchy in the system, and so maybe like the first element and the second element would be very close together on the system, and then the first element, the second element, and the third element, and the fourth element would be within the next level of hierarchy. And so I needed an algorithm that would search for work when I don't have work in a queue for a particular core. And it needed to search for among the elements that were closest to a particular element. And so I couldn't find a good algorithm for doing this, because what I kind of need to do is I call it a spiral search. So I need to check like the element that's right ahead of me, then the element that's right behind me, then the element that's 2 ahead of me, and then the element that's 2 behind me. So I wrote a little static, little spiral find if function that does this. It was a nifty little algorithm, but I couldn't think of a way to do this with just the standard library algorithms. So maybe Howard can think of an alternative way to this, but it was a nifty little thing that I wrote, and it basically each iteration sort of does check the forward, check the backwards, and then once you run out of a direction to go into, it just falls back to regular find if.
It's going to find if from the center out.
Yeah. I like the name, the spiral, and then I can like draw a little nifty diagram in ASCII in the comments describing what it does.
It sounds very neat. And no, I don't know of a way to do that with the existing algorithms.
In this class I was taking, some of the students went crazy with their ASCII art, and they had these wonderful diagrams of of the library that we're doing, because it had a geometric component, and so they were using ASCII art to show, including one guy even went as far as to do background colors by doing different kinds of hashing.
Wow.
Yeah, that does sound kind of interesting. You could imagine some kind of weird, do a sort of thing.
Yeah, I tried to write spiral sort, but that was hard.
The problem with that is that you want to stop as soon as you. I mean, that's the beauty of find if, right? You stop as soon as you.
Yeah.
As soon as you find something, so you don't really want to sort your entire data set because it's potentially large.
Well, I also wrote a spiral for each, but the one that I really needed was find if, because it's a work searching function. So as soon as the function finds work, it says, okay, I'm done.
Yeah. Spiral find if. I like. When will it be in Boost?
I'm not sure how useful it is. I haven't been able to think up an example yet that's not a scheduling example, but I'm sure there's other examples.
Well, the interesting thing here is that distance is in terms of. I mean, I can imagine a looking. You're looking for the closest thing.
Yeah.
But the way you would do that is, you'd have to sort by distance. But in this case, the distance is actually a literal iteration distance.
Yes.
So there's no point in sorting by it. The algorithm can determine that on the fly incrementally, which is what you want. So, yeah, I can see that, and I'm not sure. Yeah, I'm not sure what the applications are.
Yeah, I'm planning on doing a little bit more work with a little bit more research into this and seeing if other people have done stuff in this space. It was a interesting problem. I started looking for my copy of Elements of Programming because I was like, this seems like something that would come up in a Stepanov literature.
Could be. Well, anyway, so looking ahead, is there anything else? I think we have. Do we have any announcements coming out of CppCon? I think I've announced that we have the T-shirt contest going on. The poster contest is closed, but I don't think we have announced our poster winners yet. But I think we're going to have. It's not very many. It's. I think we had. Well, I don't want to. I don't think Hannah's made the decision yet. So we're going to have a small number of posters. Let's put it that way. And we're going to show them off during the reception on Sunday night, and we will allow attendees to vote, and we're also having a jury. So there's just going to be, because there's so few posters, there's only going to be one award, but there will be one for the jury, best poster, and there's also going to be one for attendees. the popular prize, and so we will make them available during the reception, and then we'll put them on the first floor outside of the main exhibit hall or the main plenary hall throughout the rest of the conference. So I'm really anxious to see the posters.
That sounds very good.
Yeah. What else is going on that we want to talk about?
Well, so I think I said I was going to have a keynote announcement this previous week that I did not get to because we had this has been proposal season at work, so there's been a big proposal review that I was taking part in, and we're also writing a proposal, so I did not have time to put that together. But I promise this upcoming week we will have a keynote announcement for CppCon, and I'll also do the announcement of the closing panel.
Okay, so I guess it's unfair for us to take advantage of this for CppChat, but we could tease people and let people know that that fans of CppCast will appreciate the plenary announcement, or CppCast, yeah, will appreciate the plenary announcement.
Oh, that one too. Yes, I wasn't even planning on announcing that one yet. I had a different one in mind that I was going to announce.
I thought you were going to announce the whole slate of plenaries. Okay.
Maybe I'll announce both of those together.
Okay. Well, have we teased people enough?
I think we've done sufficient teasing. Go register for CppCon.
Yes, do that. Anything else coming up that we should tease people about? The next standards meeting is ISSIQA, right?
Yeah, that is correct. It is ISSIQA.
And that is that October or November?
It is November.
November.
And right now the ballot for NB comments for C++ 17, the committee draft is out, and I think for the U.S. national body we have to get our comments in early September. So I'm working on those right now.
Okay. And so the schedule then is, if everything goes well, when do we have an official standard?
I'm going to punt on that question. I think it's a question of whether we can do ballot resolution in one meeting or two meetings. So.
Well, you've been around this a lot longer, Howard. What is your anticipation?
December 31st, the end of this 2017, at about 10 p.m.
Or like as I think happened with 14, where it was ISO actually published it in January, and Herb had to convince them to backdate it because we sent it to them in time, but just the process got dragged out.
Yeah.
So if we get it at 10 p.m., it will be early, is what you're saying.
Yeah, 2 hours to spare.
So let's see. I'm looking ahead at chats. We should be able to do next weekend. But the weekend after that, I am going to be flying back from Texas on Saturday, so won't be able to do a Saturday morning. Probably won't be in any shape to do it Saturday evening. And then Sunday, I'm flying to New York, so I don't think I can deal with it Sunday morning. So we may have to do a Sunday evening, not next weekend, but the weekend after that. But I will be full of stories of fireworks because I'm going to do a fireworks show. I'm going to Texas to celebrate my father's 85th birthday.
Awesome.
And
Congrats.
I'm going to do a fireworks show for him that is way over the top.
Try not to burn the place down.
Yeah.
Don't get arrested.
Oh no! This is all quite. They live in an unincorporated part of Texas, and fireworks are legal as long as. And I have been down there and wasn't able to do a show. I like to do a show when I go down there, but I wasn't able to do one the last two times because we didn't get the fireworks one year because I was only there for the weekend, and I got up in the morning and said to Dad, "Let's go buy fireworks," and he said, "Well, there's a big storm coming in tonight," and it's like, "Oh no!" And then the year before, when I had been down there, and I was down there for a while then, but they had a burn ban on because it's been dry and hot in Texas, and you can't even burn trash, let alone fireworks. You mention a firework and they will get all upset. So this year, there's been plenty of rain. It's very hot, but there's been plenty of rain, so they do not have a burn ban. And I have ordered more. I ordered based on how much I've paid in the past. Unfortunately, or fortunately, I guess, I think I got a much better deal than I have in the past. So I think I ordered way more fireworks than I anticipated. When they showed up, my mom said, "John, there's 18 boxes of fireworks here." It's like, oh.
I hope she has a good place to store them.
Well, I'm not so worried about the storage. What I'm actually worried about is I'm only going to be there 3 or 4 days, and so I'm actually going to probably need help to, if you do fireworks right, you need to stake them, and so I'm going to be out there staking them and taping them to the wooden stakes. And she went out and bought 6 dozen wooden stakes for me, and I will have to, and then I have to fuse them all together. I mean, you run the fuses together, and so.
I will say nice things at your funeral.
No, I'm actually doing this the safest way. It would be a lot easier to not do it the safe way. No, trust me, I'm doing it the safe way. But I'm very excited about. I've done several previous shows, but this is stepping up the scale a bit in terms of not just the amount of fireworks, but also in my approach is going to be a little bit different than I've done in the past, and I'm really excited about it. You can't, in California, you can get arrested for thinking about fireworks. So I can't do anything here. I can only do stuff when I visit my parents, and I do have to make it clear. My wife, every time I mention this, she says, "You're not doing this for your dad, right? I mean, everybody's clear about that. This is for you." And it's like, yeah. And my dad's just an excuse. I understand that. Everybody understands that. My mom was really worried because she was terribly afraid they would have the burn ban or something. She's, "You've gone to all this and it might not work out." I said, "Mom, I understand all that. That's fine. And this is my hobby. Some people spend a lot of money on sailboats, and I spend a lot of money on pyrotechnics." Anyway, so that's coming up. If you have any comments about us, you can always email me, or I think we actually have an email on //.info/CppChat. There's a link there that you can send us emails. Anyway, thanks a lot for joining us this week, and I will try to do a better job of announcing in advance who's going to be on and everything for next weekend, because it shouldn't be as big a deal. The weekend after that is going to be a little trickier, and so we may have to cancel, but maybe we can do it Sunday night instead.
And I will probably not be here next weekend because I will be in New York celebrating my mother's birthday.
Oh, well, happy birthday to her, and have fun. And we will make an announcement about what's going on this weekend, because, as I said, I don't think that's going to be a big deal. And then next weekend's a bigger complication. But thank you very much, Howard, for joining us. Thank you, Bryce. And,
thank you for having me.
Looking forward to next week. Looking forward to seeing you both at CppCon if I don't see you before then.
Yeah, I'm looking forward to that as well.
Okay. Well, safe coding, everybody.
Safe coding.
Bye.
Bye.